If you see that timer get close to 30 minutes, just let me know. I can shut it off and then shut it back on. Okay, plus 3h minus 1. With this one, because you have the negative, you have to distribute that negative 1. So you have negative 2x squared minus 3x plus 1, all divided by h. Okay? And you know you're on the right track when things start disappearing. Here you have 2x squared minus 2x squared. You have plus 3x minus 3x. You have minus 1 plus 1. Okay, so the only thing left is the 4xh plus 2h squared plus 3h, everything else is gone, all divided by h. Okay, so only all those terms have an h you can factor out. So that leaves you with 4x plus 2h plus 3, all divided by h. Make sure that goes up a little bit. Okay, just like before, our h cancels out. That's going to equal 4x plus 2h plus 3. And that's your difference quotient. For f of x equals 2x squared plus 3x minus 1. Bring that up a little bit. Okay. Any questions on that one? All right. Oh, I'm sorry, leave that up there in case people are still writing. Oh, wrong one. There we go. Have the notes here. Okay, so the domain and range of a function, just using the equation. Okay, so the two main things you have to remember here is, one, the nth roots for real numbers always have a radicand. Whoops. Greater than or equal to 0. Now for a radicand, that's just a fancy way of saying the number underneath the square root bracket. That would be your radicand. Okay. Also, you just have to remember that denominators can't equal 0. If you remember those two things, you'll basically be able to figure out the domain of any function. All right. Okay, so let's say, for example, we want to find the domain of the function f of x equals square root of 3x plus 30. I'll do both here. And for question B, f of x equals 1 over negative 2x plus 8. Okay. Now for A, we really just have to remember that whatever's under that square root has to be greater than or equal to 0. Is always greater than or equal to 0. So that means for this question, so 3x plus 30 has to be greater than or equal to 0. Anything else, you're dealing with complex numbers, and we don't want to deal with complex numbers. Okay, so we subtract 30 from both sides. You end up with 3x is greater than or equal to 30. Divide both sides by 3. You end up with x is greater than or equal to 10. Okay. So on your number line,
I got a question.
Mm-hmm.
That should be minus 30
Oh, did I read the wrong one?
because 3x.
Yep, minus 30. Thank you. Yep. So that should be negative 10. And actually, this sign, nope, I didn't switch signs because it didn't divide by negative. Yep, so x is less than or equal to negative 10. Thank you. All right, so we have your negative 10. Every x value greater than or equal to that negative 10, you can use. Okay, so your domain is just going to be negative 10 to infinity, at least for A. All right, any questions on that one? Okay. I'll do B on another sheet. Okay. 1 over negative 2x plus 8. There we go. Okay. So for this one, we just have to remember that the denominator can't equal 0. So that means for this problem, negative 2x plus 8 can't equal 0. Okay, so we just solve for x. We subtract 8 from both sides. That gives us negative 2x equals negative 8. Divide both sides by negative 2. X equals negative divided by negative is positive, so x would equal 4. Well, x can equal 4, sorry about that. Okay, so that means if you have 4 on the number line, x can equal anything from negative infinity all the way to 4, but it can't equal 4, so we use the parentheses. Okay, so back on the other side of 4, it can equal anything to the right of 4 all the way to positive infinity. It just can't equal 4 itself. Okay, so your domain here would equal negative 4, or negative infinity, sorry about that, to 4, or from 4 to infinity. Okay, any questions on that one? Hopefully this all kind of looks familiar. All right, so let me get one more example of this one. Okay, so if we're going to find the domain for f of x equals 1 over square root of 17x minus 34. And this one is different because it's a combination of both of those previous ones. You have to think about the denominator not equaling 0 and the square root being greater than 0, greater than or equal to 0. Okay, so you know your radicand has to be greater than or equal to 0, and the denominator can equal 0. Okay, so that means both 17x minus 34 has to be greater than or equal to 0, and 17x minus 34 can equal 0. So that means if it's, got my 0. If it has to be greater than or equal to 0, and it can't equal 0, for both of these to be true, that means 17x minus 34 can only be greater than 0. You can't have the equal to sign there, because then you'd have that one, and you have to make both of them happy in order for it to work out. Okay, so now that we know that, we just go ahead and solve for x. So we add 34 to both sides. Move that up. So 17x is greater than 34. Divide both sides by 17. You have x is greater than 2. Okay, so if we put that on a number line, that means every value, not including 2, but every value to the right is just fine. We can use that all day long. So we go from 2 to positive infinity. And that's your domain. All right. Any questions on that one? All right. Okay. Anyone remember piecewise functions? Or a little bit shaky on them? Okay. We're going to do a quick review of our piecewise functions. And a piecewise function is really just where you have multiple functions all on the same bracket. I mean, not same bracket, the same axis, xy axis. So you have several functions. On the same xy plane, but all of those functions are f of x. Okay, so let's say, for example, if you remember the kind of basic functions, let's say f of x equals x which we know is just the graph that looks like this. You have your x and you have your y. That's your f of x equals x. Okay. And if you remember how f of x equals x squared look, it's just a upward parabola. Okay, so that looks kind of like that. Okay. Now what a piecewise function would do is a portion of that graph would be one of those f of x values, and the other portion of it would be the other. So let's say we have f of x equals x when x is less than 0, and it equals x squared when x is greater than or equal to 0. Okay, so we're going to combine both of those into one graph, and it's going to be like half of one and half of the other. Okay, so if we combine both of those, let me move that up a little bit. There we go. So we have our x, and we have our y. Remember, when it's less than 0, it's just going to be f of x equal x. So we're going to go all the way up to 0, and we're going to stop, because this is our f of x equals x. But at greater than or equal to 0, it changes to x squared. So to the right of 0, it becomes x squared. Okay, so that would be your piecewise function. Basically, you have pieces of different functions all put together. So you can piecewise function, or you can kind of look at it like a puzzle function. You got a little piece of this one and a little piece of that one, and you put them together. Okay. So any questions on that one? Okay. All right, so let's say, for example, if we want, let's say we had the piecewise function say f of x equals, let's say, x plus 1 when, or you can just write in when, or you may see a comma, just same thing. So when, let's say, x is less than 5, and let's say it's x squared plus 4, when x is greater than or equal to 5. Let's say if we want to find, for a, f of 3, for b, f of 7, say for c, we want to find f of 0. Now, the one dilemma here is you have to figure out which function to use. And it all depends on what's inside of here and which one of these it would fall into. Okay, so for a, you have f of 3, which means here your x equals 3. So x equals 3 would actually fall into this category, x is less than 5. So since x is less than 5, at least for this one, we're going to use f of x equals x plus 1. Does that make sense? Okay. So that means our f of 3 is going to equal 3 plus 1. So f of 3 is just equal to 4. Okay. Like I said, it all depends on what's over here. You don't even know which one of these to use until you know where it falls there. Okay. So let's solve B. Actually, let's add one more and make it a D. Make that f of 5. Okay, so for f of 7, we know that 7 is greater than or equal to 5. So since our x is equal to 7 here, and actually you could actually look at this one as 3 is less than 5. We use f of x equals x squared plus 4. So once again, it all depended on that x value. Okay, so that means f of 7 will equal 7 squared plus 4, which is 53. Okay. Any questions on that one? All right. Okay, now for C, we're looking for f of 0. We do the same thing. Kind of separate those a little bit. That just means here our x is equal to 0. Okay, so since we know 0 is less than 5, which means we're going to use the x is less than 5 one. We're going to use our f of x equals x plus 1. Move that up some. Okay, so that means f of 0 is going to equal 0 plus 1, which is just equal to 1. All right, and for D, and the reason I wanted to do this one, let me move it up a little bit, is because your f of 5 is that less than or, well, greater than or equal to. So because of that greater than or equal to, that's why you use that one. Yes. Oh. Okay. So since 5, well, in this case, x equals 5, it's greater than or equal to 5, and right up underneath it, x greater than or equal to 5. We're going to use, clean that up, f of x equals x squared plus 4. Okay, so f of 5 equals 5 squared plus 4, which is 29. Okay, so it's all a matter of just plugging in your x value. You just have to figure out where you're going to plug in your x value. Okay, any questions on that one? Okay. I'll leave that up for a second in case anyone's still writing. All right. Okay. So for this one, what we're going to do is we're going to use the graph of a piecewise function to find your f values. So let's say we want to find, let's say for A, f of 0, let's say for B, f of 3, let's say for C, f of -1. Using the graph, or the piecewise graph. So you have your x, you have your y. Say this is our 1, 2, 3, 4. -1, -2. Make that 1, 2, -1, and -2. Okay. And let's just say our graph looks like this. And I'll pick this one up here. And okay. Now you see on this one we have 3 different functions. We have this graph here, we have this graph here, and we have this one all on the same plane. And you would use the x value the same way you would if it was just all on one. Okay? All right, so for f of 0, just like before, you see where x is equal to 0 and where it lies on the graph. Here, x equals 0 doesn't touch this one, and it doesn't touch this one, but it does touch this one. And that y value is 1. So f of 0, -1, sorry about that. Okay. Does that make sense? Okay. Now for B, which is f of 3, make sure it's up. There we go. Okay, so our f of 3, you just see where x is equal to 3. You can see here, it goes on this chunk here, which just happens to be 1. Okay, so we do the same thing for -1. Make sure you can still see the graph. Okay, so we know where our x is equal to -1 is. We know our -1 is here. And the reason I picked that one is because this is open. So your -1 wouldn't equal 2. It would equal -1. So you want to make sure you pay attention to the open and close circles. So it's actually equal to -1. All right. Any questions on those? All right. Oh, did anyone else have